is recorded. We see this the yield point, which is this is the yield is the limit of
elastic and plastic, yeah.
So the machine will ask you a speed for the measuring E, the modulus, and N speed for measuring the yield point, and a speed for the test. You just put the same value each place. Unless you need something specific, unless you have a standard that specifies something else, it's constant speed. There should be, in my opinion, there should be only one speed. Because some students, they forget one of the three places, and then the test goes slower and faster and slower and faster, and the curve is weird. So I don't know, just make sure you have the same speed everywhere. In my case, it's 5. For this standard, it depends, but for this norm, the standard is 5 millimeter per minute. So I put 5 at speed here. I put 5 at speed here, and I put 5 at speed of testing. Really, there's too many options. That's the problem with this software. So I put 5. Other thing, there's many options, but in my case, the test end when we reach 50% of the maximum strength. It depends. There are many criteria for end of test. But when I work with wood plastic composite, I use this. This is nothing interesting. Now the LE. This is important. I put 115, like I said. This is the distance between grips. I don't know why LE. L length, E. I don't know. Why L and E? LE speed is the speed at which the machine will go back to its position. I don't know. I put 400. I don't know.
Millimeter per minute.
It's just because.
Because it's per minute.
At this point, the test is finished. It just goes back to this position. So I don't know. It's up to you, but I use this value. After the test, so you can ask the machine after the test is finished to go back to its position. I don't do this because the tensile sample will have break, and it will go back and it will force the pieces together. I just do it. When you do bending, you can go back to the position automatically, and it doesn't matter. I don't know. It's up to you. We don't have extension meter, but we should. We don't have yet. You see in the standard it's mandatory, but we don't have it. Good. So
what is the speed of movement?
It's 5 millimeter per minute. For this,
okay.
It depends.
Okay.
It depends of the standard, and it depends also. It depends also on the sample. You have to with this standard. You have to adjust to each type of material. If you're testing wood plastic, it's on the same speed as if you test plastic. It depends. Like in this standard, it says the speeds are there is 5, 50, or 500 millimeter per minute. It depends. The test has to be not shorter than 30 seconds, but not longer than 5 minutes. So you have to adjust. It really depends. You have to read the norm carefully before you begin. So there's in all this, what's important is the size of the sample, distance between grips, thickness and width, the speed. What else?
You're talking about software, no?
This is it. There's not much.
Okay.
So there's some. It will ask for there's a specimen shape. So for us, it's flat specimen. So it will ask you the parallel specimen length. This is the distance here. So the part that is straight.
Mm-hmm.
So for your case, you put the distance between grips because we don't have the extensometer. The extensometer it's a piece of equipment that measures the strain only here.
Mm-hmm.
But we don't. But you put in here you put the grip to grip separation. It's not, to have a more precise test. You need the piece that measures the distance here.
All right.
But we don't have it. So if you have to do some kind of more precise test, you need this. But for to compare two materials, you just do like we used to do. Fine. So this is done. Then when I click LE, it will go to 115. So just move away. It should be fine.
Mm-hmm.
So I will test. Fine. If it goes like the wrong direction, you can press stop. If something goes wrong, you can press stop. I should have 115 here. This is good.
Mm-hmm.
So now after each test, I click LE to go back to the starting position. Okay. So now everything is ready to begin. When I begin, I always do some kind of dummy test before I take any piece of wood just to test if it works good before I start, because in the beginning there's always something wrong, but now that I'm used to it, it's fine on first time. So I put my sample inside of it, but before I take its measurement. For each sample, you have to measure the thickness and width, because each sample is different. If you have very low variation, you can take the average width for every sample. When it's molded, it's pretty similar for each formulation. So it's up to you. But the more you measure, the better the precision you have. So I measure the thickness 3.19. Let's go here, 3.19, and the width 12.57. So there's a small difference. Now I can put the sample inside of it. The grip at one is much better than this one. I put it on the center. It's about here. It's about at the center. Now, because I work with it, there's a force of -3. It should be 0. I just click 0. 40.
Mm-hmm.
Before every test, I click 40. It's always varying a bit because it's very precise. Then LE should be fine.
Mm-hmm.
Then I'm ready to go.
So it fits automatically, or you should do it manually?
The one at one, it's a screw that you just screw it.
Okay.
And it's self-tightening, so the more it pulls, the more it grips.
Mm-hmm.
At one, it's a screw you just tight, I don't know, just like you would tight a screw or something. Just make sure it's fine. I'm ready to begin. So I just put start. Maybe that I forgot something. I don't think so. You should wear glass.
Mm-hmm.
Oh, then it will ask again the size. So if you forgot to take the measurements, then you can do it. You can ask the machine to ask you or not this.
Okay.
But most of the time, even I put the sample on the machine and I forgot to measure. Then I had to put it out and measure and put it back.
Right.
Then this is okay. Then it goes on. You see the curve. This is bark, so about 22 megapascal. I don't know why there's a mark here. In my case, it has to last at least 30 seconds, so it's a good speed, but not more than 5 minutes. With WPC 5, it's usually good, but with higher wood content, 5 it's too quick. It depends on the material. We get the maximum at about close to it. So 950. So at half of this, it will stop. Like 450. About. The test will end. As I put this criteria, but it could be something else.
Yeah.
But WC, usually they break very quick. They break very. It's brittle. It does not strengthen for forever like plastics.
So it has creepy behavior.
No. Yes, it has. Yeah, but I mean it. When you do this test with plastics, the test could last for an hour because it will étirer. It will stretch forever. It won't break straight like this. So this is the So just to show you an example of if I press LE before I remove, or if I ask to go back to LE automatically, it will touch the sample like this.
Yeah, exactly.
So you don't want that.
All right.
So now there is one last thing to do. So now it's ready for the second. So I just measure the second, put it and press start again, and so on. I suggest you to save in between every sample's file, save. Because if there's a bug, if the computer freezes, then you lost. You lose all what you've done, and your sample, and all the work that is before. Or just Control S. So there's one last thing to do is to adjust the measurement of the modulus of elasticity. So there are different ways of measuring the modulus, but in all cases it's the slope and the linear part. So I prefer to use the secant. It means it takes 2 points and it draws a line.
Secant modulus.
No, a secant, yes.
Or tangent or secant, yeah?
There are tangent, secants, regression.
Regression, yeah. It's kind of how it calculates the modulus. Okay.
Secant, it takes 2 points and it draws a line.
Yeah.
And it takes the slope. Tangent, it takes 1 point and it calculates. I don't like this because if I take tangent here, I could have 0 just on the if you're bad lucky. But if you can take 2 points, it's better. I never tried, but there is regression. Whatever. I like secant, but up to you. So then I have to choose the beginning and the end point in the linear zone. Like for this case, I'm at 7. It's fine, and 18. 18, I'm no longer in the linear zone. So I have for each sample. So there's one value for all the set. So when after I've done all my curves, I choose a zone that works for everybody. But usually, you have one file for one set of sample. Like if I repeat this formulation 10 times, I do my 10 tests on one file, and I save it as I don't know, it's popular bark 40% something. So if you have like you have 9 types of samples, you have 9 files.
Okay.
So let's say I could put like 4, doesn't really matter, 4 and
10.
and I would say 12, but it's up to you. It has to be in the linear zone.
So the machine gives you what is the maximum amount of linear?
No, you have to see. I say it's about here.
Oh yeah, you just guess.
Yeah.
Okay.
But so image list. RP is the
tension.
The yield point.
Yield stress.
This is proportional resistance. So X is for in my case X is 0.2% plastic deformation. So you see it's about here. It's about where the linear end. So it's about it's about 16. Well, and he put 90. It's about here. The work to break, or is it the work to? Let me see. Work to break. Okay. This is the area under the curve. This is the energy up to break.
Yeah.
This is the maximum resistance. Is 24 about here, as you can see, and the strain at break it's about here 9 and something. I always look at the numbers if they make sense, because sometimes they can be an error.
So in the case of wood plastic materials, this amount, if it's be higher or less, which one is more better if you want to compare different materials?
Which parameter?
Yeah. Tension at the.
Usually the higher is better, but it depends what you want, because usually when it's higher resistance, it's lower in strain. Depends. Do you want high strain or low? It depends on your applications.
Yeah, but what I want to understand is that when we have a higher, it means that the elastic part is much more.
No. It says RP. It says, oh yes, I understand. It says that the linear zone is longer.
Exactly.
Naturally, I mean, it says what's the maximum stress before we fall into the plastic part. It means the material should be used in the linear part. Otherwise, it would be permanently deformed. So
yeah, the thing is, I want to try to understand. What we are using is basically, I don't know, 50-70% plastic material. Okay, so when we have a more linear part, it means the effects of our additional wood or something is more predominant or not. This is what I try to understand.
It really depends. Usually with pure plastic, you have just no linear part at all.
Yeah, exactly, because it's plastic.
Yeah, so it depends.
Because this is the aim of adding woods on it.
Well, I think the aim is to lower the cost. Really, it's it's about that.
Yeah, but anyway.
But
because I found it in my samples. I want to know between this one and that one, which one is better? The one that has more elastic part or the one has more plastic part?
It depends on your application needs. I would just not use the word better at all, because it's depends.
Can I say if it's more linear, it means we have more wood on it?
Sometimes it is. Example, for decking, you like to have a linear part because it's not going to deform.
Yeah.
For example, so now I set the range of for the modulus, but it has not applied yet. I have to select the samples, like Control A or Specimen Management, select all, like select all samples. Okay, it's done already. So like select all samples, but now they are all right. Or I just use Control A. Anyway, then I have to ask to recalculate with the new values that I set for. So now I do evaluate. You'll see it now. It's 0.663, 0.754. If for any reason I change like here the value, the thickness. If I put like, let's say for example, I just do this at first, I just miss the comma, then it will do something like this. You know, I have like values that are very, very big. I can put it back, yes, but it does not apply. I have to ask to evaluate again, and then it's good. So you have to after the test you can redo everything, but not the raw value. You can recalculate everything. You can add some more sample result if you like. It's very it does everything, but at the same time it's hard to work with because you have to know everything. So it's tricky, but the possibilities are there. So this is it.
Okay.
I suggest you to remove all this and begin again while you're here, or you can begin your test.
I don't think so, because I have a lot of things to do at once.
Yeah. So you prefer to work at one. I see.
Yeah.
So, right. So this is it. It's I can save. Keep this file. So keep this file on the flash drive. So when you will begin again, you want to remove this curve. So you just select all, right click, or go to Specimen Management and you go delete. Say yes. Now it begins with 3. You prefer to have 1. You can right click here on series and then number the specimen, and it goes back to 1. But if it begins with 3, that doesn't really matter.
So if we want to do a test, do we have any sample or something? And also we need that file to get it from you, or?
Yeah, because it's already all prepared and
exactly.
It has been tested. You know, there's always something wrong. We worked this file for a long time, for many times before it was as we need.
So I give you a flash memory just to transfer it.
It's right here on the
desktop. Okay.
Where is it? Oh God, I hate this machine. I hate it. Put this file where? I don't know. So I will save as, then desktop. So Tensile training by backend Makta. Yeah, you will lose file, you will lose data, everything will happen. I promise. I worked with this software at the first time in 2006. Now, after